So, we're going to transition from a panel that talks about collaboration to now switching to talking about how and what we're doing here. And this is going to be a transition into implementing some of the ideas through a smart manufacturing roadmap and what that means for our practitioners. And for that, I'm going to welcome our next lead for this session, Matt Littlefield, the President and Research Lead from LNS Research. Let's welcome him up. Thank you, Jeff.
My name is Matt Littlefield, President and Principal Analyst here at LNS Research. We have had the pleasure of working with SESMI for a number of years, both as a partner and a proponent. And a big part of that is our shared mission and vision for the industry. And we are here to empower industry leaders to transform their organizations. And that's a big challenge I hear a lot about. Every time I ask somebody, what's the big challenge you're focused on? It's culture, it's that smart manufacturing mindset. And our vision is one where industrial companies are agile, autonomous, and sustainable. So this is one of my favorite slides, favorite data points, really showing the growth of smart manufacturing since we started asking this question back in 2015. It is no longer, and I heard folks talking earlier today about early adopters, fast followers. We are past that stage in manufacturing. So over the last few years, we have really helped eliminate and move past not just the folks that are going mainstream, but the detractors, the skeptics, the folks who say, hey, that smart manufacturing thing's not going to work, it's not for us, we shouldn't try it at our company. There are very few, only 12% today, of companies that still believe that. So we have captured the hearts and minds of folks today. But as more and more companies adopt smart manufacturing, as they go on this industrial transformation journey, a new set of challenges emerging. And there are two main challenges we see. One is on people and buy-in. So first and foremost is the next generation of labor. Right? We have been losing talent for the last decade that has dramatically accelerated since COVID. We have built a network of manufacturing plants that are designed to run with 30-year veterans, with significant time in position. Today, we have a workforce of 3-year veterans with very little time in position. And what does that mean? That means that, hey, a third of my workforce or more are 6 months in, constantly churning. So the systems, the processes, the approaches that we took when we had 30-year veterans won't necessarily work when we have a team of 3-year veterans. The other big challenge we see is scaling. Everyone here has a quick win. Everyone here has run a pilot, or almost everybody, maybe 12% haven't. But it's very different to go from a quick win, low-hanging fruit, and pilot to scaling it across a network of 10, 100, or 1,000 facilities. Or even more, like we're going to talk about today, a roadmap for scaling that across an entire ecosystem, an entire value chain. So that's what we need to figure out, and that's why companies need a roadmap. So you've probably seen some of the data out there around productivity. And manufacturing labor productivity has been stalling. It has been flatlining for the past decade. So we have, and this is an early preview, we launched this last week at our event, launched an industrial productivity index, looking at how companies, based on their real financial data, are driving productivity gains across their global businesses. So we're looking at 166 publicly traded companies. That represents $3.8 trillion in delivered products a year across 8 industrial sectors. And we look at revenue, cost of goods sold, assets, and then price changes, PPI and CPI. And so overall productivity is not quite as bad as labor productivity. Growth has been about 1% a year for the past 10 years. But when you dig into that data, and I was talking to Jim Davis earlier about fragmentation. When you dig into the data, only about 8% of companies are driving that productivity gain. We call these productivity pathfinders. They're the companies who have long and short-term growth in both productivity and revenue, and they are capturing all the value. The other 92% of companies are flatlining on productivity. And productivity drives wage gains, it drives and is the engine for our economy. So if we want to change the tide, if we want to move past this flatline productivity gain, sort of the end of that Industry 3.0 era, what do we have to do? We believe it starts with strategy. Can't end with strategy, you have to execute, but it starts with strategy. And this is our strategy map. At the highest level, you hear us talk a lot about Operations 2030. And these are your business objectives. It's M&A. It is organic growth, it's cost reduction, it's whatever your organization is focused on. You have to have globally aligned metrics to support and drive towards those strategy. We believe you need step change improvements. You'll hear us talk a lot about the journey to zero plus. So zero harm, zero waste, zero net carbon, plus step change productivity growth. And then you have to support that with your strategic initiatives. And we think those initiatives need to be driven by people, process, and technology. And then those initiatives have to be supported by an architecture, change management capabilities, and value chain integration. And this is where SESMI comes in. This is what they target on. They provide that architecture, and what we'll be talking about today is how to do that value chain integration. This is our version of the architecture needed to support a smart manufacturing journey. At the base, we talk about industrial networking and compute, industrial cybersecurity, layering on top cloud platforms, app platforms, and data platforms, and eventually those open and interoperable applications in the industrial space. And the key elements, and this again is where we see a lot of alignment, is on open, scalable, interoperable, plug-and-play, and human-centric architectures. So those companies that drive that strategy, that connects across people, process, and technology, and support it with an architecture that's flexible and open and interoperable, really do drive to significant business benefits. So we call these industrial transformation leaders, and on average, they have an increased revenue growth of 10%, cost of goods sold reduction of 10%, and operating margin increase of 5%. So, thank you for letting me set the stage. Anytime you want to drive a change, a transformation, a culture shift, you have to know where you are, but you also have to know where you're going and how to get there. And that's what John and Jonathan have been working on, and I've had the privilege of a preview of what they have to share, and it is going to help change this industry. So with that, I'd like to introduce John Dyke, CEO of SESMI, and Jonathan Wise, Chief Technology Officer, SESMI.
Well, good afternoon. I feel like I'm back. Didn't actually go very far away, but it's again a privilege to have this time with you. My colleague Jonathan Wise will join me on the stage here in hopefully about 15 minutes to talk to you about one of the most exciting things that we've had the privilege of working on for the last 12 months or so. We were approached by a collection of automotive organizations, automotive manufacturers, some of the most sophisticated manufacturers in the world, to put together a roadmap for the automotive industry. And we've had the privilege of working with them, interviewing them, doing the research, the analysis necessary to deeply understand the challenges faced in this industry. And then most importantly, what does that look like as we look to the future? What does smart manufacturing mean for these already sophisticated, highly integrated, highly automated manufacturing organizations, but with a supply network that is much less integrated, much less automated, and much less disconnected. And so we have a few moments today to share with you the outcome of this analysis, the roadmap itself, and some further commentary by organizations that are now, as a part of this broader ecosystem, will be joined on the stage here by a number of other organizations that are here to underscore the importance of a community, an automotive community, not an ecosystem. They actually told us they prefer to be discussed and to be engaged as a community, not as an ecosystem. So I'm going to try to do my best to keep that straight. As a community, to solve big problems in a pre-competitive way that are going to help the entire ecosystem, the entire community, not just the large manufacturing organizations. And so what I'll do is just take a few minutes at a very high level to look at the intersect between the work that SESME is doing here as the Smart Manufacturing Institute focused on all industries, and what that looks like in the context of one industry, which happens to be an important industry here in this state, but obviously in this country more broadly and globally for sure. These are the 6 business challenges that were raised among many, that were raised to the top in terms of what these organizations want to accomplish through the value of information, through the value of a transformed culture, through the value of a connected supply chain globally. And I won't dive into these, you've probably had a chance to review them, but it's about manufacturing productivity, it's about new program launches, it's about addressing workforce churn, which 3 years ago wasn't an issue and very quickly became one. More granular and real-time data from suppliers, and this is a little bit about back to the International Manufacturing Acts initiative, revitalizing many of these strategic initiatives, safety, quality, continuous improvement, that have plateaued in many ways based on the legacy or the existing systems and the extent to which we could leverage data historically. And then, of course, the corporate strategies and the funding that has to be aligned with a vision for the future, which is absolutely an issue for almost every manufacturing organization, big and small, that we have the privilege of working with. So these are the issues. If you've heard me talk before, you will have seen this slide, I guarantee you, but I can absolutely state beyond a shadow of a doubt that this image, this story, resonated 100% with the manufacturing organizations that we've had the privilege of working with. The fact that after a massive investment of significantly mature, sophisticated, albeit Industry 3.0 centric manufacturing systems, they have a huge installed base of what I call technical debt, of data silos, stovepipe architectures, vendor lock-in, that still compels them to do significant hand-waving, and in every single plant across 65 or more plants, they spend 40 people hours every shift moving data from this disparate collection of systems into the systems, dashboards, Excel reports that they use for shift handoff activities for production quality and maintenance. So this is the state of the industry, and this is where the transformation has to happen from a technology perspective. And I should add that the roadmap itself is a very technology-centric roadmap. We've paid homage to the workforce and the development and the transformation of a culture, but by their very definition, what they needed and their mandate, what they needed was their help with the roadmap, a technology roadmap that was going to drive the entire industry forward. Here's the fascinating reality. After 12 years of Industry 4.0, they're still investing in use cases and in systems and in architectures that reflect the last 30 years of data silos and stovepipe architectures, which begs the question about what does Industry 4.0 mean, and are we realizing the value of Industry 4.0, and why are we propagating the same level of cost and complexity today that we were 10 and 20 and 30 years ago? So if we take every one of those systems, and by the way, that's an actual manufacturing systems taxonomy from a Fortune 50 manufacturing company. If we take those manufacturing systems and flip them on their edge, you'll see that all of those roughly 60 systems have their own proprietary data connection strategy, their own proprietary data collection, data store, data contextualization infrastructure to accomplish whatever that application needs to accomplish across maintenance, production, quality, logistics, et cetera. What that looks like, though, is that collectively, they're duplicating, replicating data stores, application infrastructure, people's times. They're replicating significant, absolutely significant costs and complexity for every single one of those applications because they were born one use case at a time and propagated one use case at a time without a holistic manufacturing strategy to undergird that path forward. What is the impact of that? Well, for the large manufacturers, we understand they have the deep pockets to do something. regardless of the cost and complexity, and that's what they've been doing because that's what they had to do. The irony is the medium manufacturers and the medium sites of any sized organization struggle to engage, and certainly the small organizations, the small manufacturers, and the medium manufacturers themselves have a significant challenge actually even engaging in this space from a transformation perspective. And so we won't dwell on this, but some of the analysis that we did for this organization, for this community, involved a significantly sophisticated look at the various different types of production systems that represent the automotive industry and, of course, more broadly, other types of manufacturing operations. And this was one of the exhibits that we came up with along the way early in this process to say that there are huge complexities from manufacturing type or production type to production type that are a function of the automation strategies and systems, that are a function of the types of manufacturing application infrastructure that's deployed in each of these areas as I walk through this, but most importantly, as a function of your application infrastructure, the different types of context that are key and unique to each one of these production types. And the reality, the realization that across different types of manufacturing, there are enough disparities from one production type to another production type to relegate most applications in this kind of level 3 smart manufacturing space to the production type that they were born in, meaning there are enormous complexities and significant cost if you take an application that's born inside this box, make-to-stock, discrete manufacturing production type, trying to apply it in a make-to-order environment or in a batch hybrid make-to-stock environment. And so helping the ecosystem, the community, understand that the complexities that we've created, this technical debt that we've created for ourselves as we've grown up over 3 decades of trying to figure out how to connect machines, how to connect processes, how to bring the human beings into this mix. We've created a legacy of complexity that we need to understand better and make sure as we develop future architectures, next-gen solutions, next-gen systems and thinking, next-gen mindsets, that we fundamentally address these complexities and don't make any more assumptions about the ability to move one type of application from one of these production types into another unless you've preemptively architected your solution to ensure that that's feasible. So we've kind of graduated to the point where we have over 30 years a set of manufacturing processes, systems, and standards that come out of this as a function of the Purdue model. I think most of you have probably heard of the Purdue model. But that complexity that really constrains so much of the adoption of smart manufacturing here in this country and around the world resides in that level 3 space, and the flow of information has been significantly constrained because of those complexities. And so as we think about the future, and this is the sort of roadmap process that we put together that we'll be sharing with you, as we think about the future for the automotive OEMs, the tier 1s, 2, 3s, and the machine builders, the entire community around them, we have to, and this is back to the international manufacturing strategy as well, we have to be able to think about infrastructure that will support the agile movement of data from any layer in a manufacturing operation to any other layer in that manufacturing operation, enterprise, and supply chain. And what that takes is a whole new rethinking of smart manufacturing infrastructure. And thankfully, this is not day one of that. We've been working on this together with our friends from Germany, as you've heard this morning, for many, many years, not just on the technologies and the architectures, but on the education, the ideas of interoperability and standards to facilitate this and to bring this to the marketplace in some very, very compelling ways. Step number 1 is to recognize that these monolithic applications are no longer acceptable. So how do we change that? Well, what SESME has done with our community, with our members, is to divide that monolithic architecture into 3 important layers and develop together with you a set of open, let me say that again, a set of open specifications at the edge of each one of these layers that we are capable, that we have been giving back to the marketplace as a sanctioned, well understood, robust set of open specifications that will enable the kind of strategy that we've been talking about going forward. And then most importantly, the edges of those layers of this architecture are informed by standards-based information models that can be crowdsourced, open sourced, developed by subject matter experts, and not created as proprietary exhibits, proprietary deliverables inside every plant, in every technology platform, by every vendor. And so this notion that there's a marketplace with a repository of crowdsourced, globally available set of information models, that those information models can then inform those interfaces, that we believe is at the foundation of an interoperable architecture that is future-proof, that can enable manufacturers small and large to engage in a much, much more cost-effective and simple way in this space. This is how we reduce cost and complexity. In essence, bringing the best of the IT world into the OT world and actually enabling a level of collaboration between OT and IT that I believe is at the heart of why we haven't seen more of that convergence taking place yet. And so, as we think about the history of how applications have grown up in the automotive space, one use case at a time, and really every industry, one use case at a time, with one stovepipe architecture, one data silo at a time, we need a culture that supports and sanctions the idea of a larger, longer-term strategy, a smart manufacturing mindset that underscores the DNA of the entire organization, and the architectures, the capabilities that will embrace and extend that installed base, but also make way for another whole set of next-gen smart apps built much like the applications on your device today against open, scalable interfaces, whether that app is a $1 app, one dashboard, $1 app, or whether it's a sophisticated analytics, AI machine learning model, or whether it's an MES system going forward, all built against an open set of specifications, avoiding vendor lock-in, avoiding this vendor data silo stovepipe architecture. So with that said, we believe that facing all of you always has been and always will be this choice to build or buy your way into a new smart manufacturing architecture, a new smart manufacturing mindset looking forward. From our perspective, we believe it's vital, and what the automotive community told us is it's vital to support both a build and a buy strategy. And so we've created the guidance through the roadmap to engage with them where they are to ensure that regardless of whether you're working with one of the great technology providers that you see in our community here in the SESME booth, or whether you choose to build your own, you have the choice to build against the same open interfaces and architectures regardless. And in fact, that is, I think, what you as the manufacturing community deserve to anticipate and expect from the broader community. You've heard today that we're not going it alone, that we're part of a much more significant ecosystem, there I go again, global community to ensure that we're engaging with the right organizations, practically minded, advancing the state of the industry as a harmonized set of activities, standards advocacy, and engagement. And so we're going to be hearing more about that from a few of those stakeholders here in the room with us today. I'm winding down, I know I'm a little over time, but this notion of a smart manufacturing mindset became super, super important for us through this process. It's become kind of the buzzword for 2023 for SESME. As we transform the industry one manufacturer at a time, this will happen if we build the idea of smart manufacturing into our DNA so that like quality, like safety, like continuous improvement became part of our DNA over the last 3 and 4 decades. Smart manufacturing has to become part of our DNA in a much more sophisticated way going forward, and we are working on that as a mindset, developing the idea of a playbook together with the team, the membership, our partners here at SESME. With that said, I'd like to invite Jonathan Weiss, VP of Technology here at SESME, to talk to us with a little more depth about the roadmap, the technology specifics. Jonathan?
This was an interesting experience for me. I started my career making information software for the automotive industry. So when we were approached to build this roadmap, it was a fun experience to dive back in. If you've heard me talk before, you probably won't be surprised by kind of any of the advice that we offered. But it was neat to see kind of where this community was in their journey and kind of help shape a vision for where they needed to go. You heard a bit from our friends in Europe. I think you're going to continue to hear from them, very much setting something of a destination. I think in many ways they're ahead of us in thinking about what the end game for this looks like. In US manufacturing in general, we have some work to do. And in automotive, they're at a kind of a point in that journey, and our task was to shape this roadmap to help them take next steps on the journey. In Katina X, which I think you're going to hear more about, they're thinking already about how we securely broker and share necessary data between participants. Some of their specifications are available now on GitHub. As we worked with this group of automotives, they also had some emerging specifications that were sort of earlier in this process, not at the point of sharing the data, but understanding what data needs to be shared and how that should look. So we started from that point in their journey and put together a couple of milestones that we think they need to include on that. So I'll go into a bit more detail on each of them, but they probably shouldn't be a surprise if you've heard any of our messaging or if you've been by our booth. It starts with establishing a description of the data that you need from a given system to solve a given problem. SESME calls those profiles. Profiles are based on an open standard that we borrow from the OPC Foundation. Part 5 of the OPC UA specification describes an information model. And information models become contracts. They define what multiple participants need to share from a system and to a system in order to solve a given problem. So we start very early in this roadmap with defining information contracts or profiles. John laid down the challenge that every manufacturer needs to build or buy a smart manufacturing platform. A smart manufacturing platform needs to address a couple problems that I want to talk about today that we covered in a fair bit of depth in the roadmap as well. And then we think you're approaching the point, or you're beginning to approach the point where you have data, you know what it looks like, and you know where it is. How do you securely broker that access to that data to the folks who need it in order to solve a problem? And then finally, how do you expand that sharing beyond your enterprise and to the other enterprises that you're dependent on into your supply chain? The 3 problems, and this is I was encouraged to do this at a high level, so if you want to dig deep into any one of these, we can, but the 3 problems are related to getting access to the data and making sure it's consistent, understanding where the data is coming from and what it's related to, and then making sure that we have accessibility to that data both now, its current value, and historically. There is a kind of core thread that goes through all of those problems. That little icon there is what we use for the profile. The profile is used throughout to help solve all of those problems. And although we borrowed the OPC UA specification, this concept of describing data even before you have the data is not unique to us, to the OPC Foundation, or to this roadmap. It is an object-oriented programming principle that in computer science we've used for the past 30 or 40 years. And in manufacturing, we've done kind of a poor job of mimicking in a number of our systems and platforms. So we really think that this profile concept is the seed, it is the core of any smart manufacturing platform. We started about 2018. We kind of had this philosophical concept of a profile. We started looking at what the industry could use, what the industry would be willing to adopt to embrace this concept. We looked at a number of proprietary offerings even before this roadmap, a number of implementations of this concept that existed. The only one that we found that could do everything we felt was necessary, kind of fully embracing object-oriented programming concepts that wasn't encumbered by somebody else's licensing rules, that was truly open, was OPC-UA Part 5, this information modeling language. OPC-UA Part 5 has been around for a while. The early versions of the specification date back to 2011, but the uptake here in the US was rather disappointing. This is an open language to describe information in a system, and largely people were thinking of OPC as a communications protocol, harkening back to the 90s, and maybe comparing it to other protocols and not really understanding that there's like 17 parts of the specification, each trying to address different problems that we all face. And Part 5 is remarkably neutral. Part 5 is a specification that anyone can adopt without necessarily adopting the other parts of the specification. So if MQTT is where you're going, you can actually implement UA over MQTT with Part 17, but you can also just pick a Part 5 information model and implement it in your broker. This applies to any protocol or any means of communicating information. We need an externally authoritative document that describes what that information will look like so that we can separate concerns. So the people that are trying to turn that information into value know what it looks like when it arrives. So the people who are doing the electrical wiring to make sure the data can flow knows what data needs to be present in the system. The people programming the PLCs can use a profile as a specification to work against. It can be used throughout the model. One of the kind of theories we had for why maybe adoption wasn't what it should be was a discoverability one. So we partnered with all three of the major cloud vendors, co-led by Eric from Microsoft, and created a specification for an open cloud library. So part of the roadmap is the recommendation to these automotives, but also to everyone in this room, that there is a free library that can be searched by humans and by software to find information models that experts have created for you to use. I've heard probably a dozen stories already this week about people building systems, invariably taking their best guess at what data should be present and how that data should be labeled. This is not how we build reusable software. This is how we end up with layers and layers of custom software that's not interoperable. So in partnership with these groups, we created this cloud library. SESME hosts a version of the cloud library. The OPC Foundation hosts a version of this cloud library. We recommended to the automotives, we're recommending to you in the room, to go look in the cloud library to see if anybody's already solved problems in your space. Because most of these information models have been created by expert groups with the intention of reuse. This drives consistency. Here's some of the folks that are working on driving consistency through these information models. The consistency is what data should be present, but also it's the ontology, the truth of this data, how it should be called and how it should be used. And it's all completely free. This is an example of one of the profiles that we shared in this roadmap. Robotics might not apply to everyone, but you'd be hard-pressed to find an information model that doesn't apply to you in some way. These are created by working groups. They convene experts, but they also don't know every one of your applications. A profile allows you to derive and specialize. It allows you to take a core that is common, repeatable, and interoperable and specialize it for your use case, and then optionally share that back with the rest of your community. So this is one of our recommendations as well. We often start with something like a class diagram. If you're not a software developer, that's okay. You don't have to start with a class diagram. You can start with a list of tags that are important to your problem space. But you need to evolve towards something that's reusable. The next set of recommendations, the next set of problems, are around once we have this data. We should have this data as objects, not as key value pairs, not as lists of tags. Eventually, a profile, a class definition, allows us to create objects. Objects, like in object-oriented programming that we've been using in IT software development for decades, are rich and capable structures that allow us to interact with our data. But objects don't exist in a vacuum. Objects exist in relationship with each other. And traditionally, the software available in our space expresses those relationships as a hierarchy. So this hierarchy might not be yours. This was maybe more specific to an automotive plant. But generally, if you're using any sort of information software, you likely end up building an asset model, and that asset model has parent-child relationships. Something belongs to something else. And that does facilitate some analysis. I can summarize what happened to my children in a parent object and build a report. But what it doesn't take into account is that relationships between objects change. This finished good, as I'm making it, has a relationship with different parts of my plant as it's moving through the assembly line. It has a relationship with different operators that are interacting with it. And if I want to be able to really analyze what's happening in my operation, I need to be able to capture all of those relationships and store them. The relationships are of objects, but between those objects and between those objects over time. A hierarchy is far too limited, and we have been hamstrung by software that insists on hierarchical models since I began writing software in this space in the 90s. A graph is what we use in the rest of the world. So if you were at any other conference, the way that you relate your data is graphically. The objects have multiple relationships with each other. One way of describing that might be as nodes and edges. So each object is a node, and it has edges with other nodes. You have this in your life. You have parent-child relationships. You have peer relationships. You have a boss and an employee relationship. Our relationships are in graphs. Manufacturing relationships also need to be expressed in graphs. The other thing that we need, and the other thing that we recommended in this roadmap, is if we have this set of objects that have standardized sets of data, and we have these relationships between these objects, do we have an interface, not just a user interface where we can see this data, but a programmer's interface where we can harness this data for modern software development? The kinds of magic we see happening with ChatGPT on the rest of the world, it's based on relationships. And it's based on the fact that largely the corpus of the internet can be read programmatically. I can train these models by making HTTP requests to sets of data across the internet. This is how these things grow. We don't have any consistent APIs in manufacturing. There are some APIs. Generally, they arrive around level 3. Largely, our systems are architected along the lines of the Purdue model, and they are proprietary. They're some vendors' API, and as John showed, we have lots of vendors offering lots of different software packages, only some of them offering APIs, and none of them consistently accessible. So kind of the third set of problems we addressed in the roadmap is the availability, the accessibility of APIs that allow me to get access to the data. That data has to be the current values. It also has to include the historical values. So historization is something we all know about. But it's got to go beyond the samples, or in automotive, we often think of events. And it's got to include the history of the relationships. If I'm an operator that's working on a line and I go home, that relationship has at least temporarily ended. And another operator comes on shift, a new relationship is established. So if I want to write information software that can analyze what operator was on a line when a thing happened, I need the history of that relationship to be a part of the API. These are the benchmarks for what we consider a smart manufacturing platform. This is part of our recommendations. And in this industry, they've gone pretty far down the path of trying to address these problems with something called a unified namespace. And a unified namespace is not a bad thing. A unified namespace does address some of these challenges. One of the goals of a unified namespace is to have common naming for points of data. But a unified namespace is a hub and spoke architecture. There's only a couple different roles in that architecture, and it largely hinges on a message passing mechanism, usually called a broker. A broker is a decent message passing mechanism that can be used for pub sub, which happens to work well in this industry. But by itself, the specification that underlies it, MQTT, is missing a few of the pieces that we identified as critical in this roadmap. One of them is history. A broker doesn't persist history. You need proprietary implementation that adds history to the specification. The other is an API. A broker does not include an API. MQTT itself has a way to subscribe to data, but that is not an API. And a broker cannot, by definition, persist graph relationships. At best, we get a topic naming convention that is hierarchical, mirroring what we had in the 90s. All of these things kind of add up to a set of requirements that SESME believes are necessary to call a platform smart. This slide is actually from LNS, so this is not my slide, and they've identified some of the same things. Developer tools and libraries, what I would call an API, and an API is table stakes in any other industry. I've been writing software for nearly 30 years, and if I encountered something that didn't have an API, I wouldn't use that thing. But we do in our space. For some reason, it's acceptable for our vendors to trap our data in their proprietary systems. And we can't work that way in 2023 and beyond. Our version of this picture adds kind of some of what John was talking about earlier. Our architecture needs to support a wide variety of applications. It's a common architecture, but for different use cases. This is what it looks like at a very abstract level. These three problems map to kind of three layers of an architecture: the acquisition of data, the coherent structure and storage of that data over time, the relationships in it, and then the secure brokering of that data to an application layer that can turn that information into insight. If we complete the picture, the end of the roadmap includes the data spaces in which that data lives and is securely shared with the different participants that need access to it. But I think you'll hear more about that later. This is the SESME implementation of these ideas. Importantly, we think anybody can implement a smart manufacturing platform if they meet the requirements we've laid out. If you want to see our implementation of it that we've built with our ecosystem, the booth right behind you has a couple different ways that we exercise this. And I think I have to turn this over at this point to Matt to wrap this up. I think the kind of final point is that while we talked about this in the scope of each of these automotives, and we would talk about it with you in the scope of each of your operations, we really begin to solve industry problems when this level of data standardization and shareability, interoperability is available across supply chains. When I can tell from my supplier what their constraints are in a secure, appropriate, and brokered fashion, I can plan better. When I can forecast to my customers the things they need to know about my operation, they can plan better, and we can better interoperate across supply chains. I'll leave this up as I leave the stage. These were the milestones that we laid out. Although they were specific to kind of this request for guidance, I think they're generally applicable. You might each be at different points in your own journey, but we would love you to consider where you are at each of these milestones. Thanks.